Welcome back. We are looking at Lecture 19 and solving systems of equations. We've looked at substitution. Now we want to use the method of elimination. And this one simply says, let's see if we can combine our two equations into one to eliminate a variable. So that's our goal. That is assuming we can get this to focus properly, which it does not want to do. I've been having such difficulty with the focus on this. There we go. Okay, so let's look at an easy one. We notice that we have the opposite plus 2y and minus 2y. So I'm going to do something very simple. I'm going to add my two equations. And in so doing, I eliminate a variable, because 3x plus 5x gives me 8x, plus 2y minus 2y gives me 0, 4 plus 8 equals 12. Okay, and in one step I've eliminated the y, so 8x equals 12, and it looks like x equals 12 over 8, and if I divide by 4, that's 3/2. Okay, so now how do I find y? I'll take either equation. Let's start with the top equation and plug in x. Okay, so we're going to this equation. So 3 times 3/2 plus 2y equals 4. Okay, so 9/2 plus 2y equals 4. 2y equals 4, which is 8/2 minus 9/2. 4 is 8 over 2. Okay, and so it looks like 2y equals negative 1/2, so y equals negative 1/4. Okay, and it looks like our solution should be 3/2, negative 1/4. Okay, but I want to check. In equation 1, I substitute 3 times 3/2 plus 2 times negative 1/4 equals 9/2 minus 1/2, which is 8/2, and sure enough, that's equal to 4. We say, well, yeah, that's how we came up with the negative 1/4. What about the second equation? Okay, so 5 times 3/2 minus 2 times negative 1/4 is 15/2 plus 1/2, which is 16/2, which is equal to 8. And so it checks in both equations, and so that is our solution. Okay? How about the next system of equations? Now here I have to do more work. I can't just combine the equations and have a variable be eliminated, so we're going to go through some steps. First of all, in the top equation, we're going to do the usual step that we have with equations. When we're trying to solve, we're going to clear fractions. So I'm going to multiply both sides by 6. Okay, and if I do that, I get 6 times x over 2 minus 6 times 2y over 3 equals negative 2 times 6. Now why did I choose 6? Because that's the common denominator, the least common denominator. Okay, if I do that, I get what? 3x minus 4y equals negative 12. So now I have a new system. Okay, and negative 6x plus 8y equals 24. Okay, so I've got my first, or better form, improved form of that system, but it is still not going to be correct because I can't eliminate a variable yet. So what I'm going to do is manipulate the system. Notice that if I multiply by 2, I should get a cancellation because I'll have negative 8y plus 8y if I multiply by 2, or I'll have 6x and negative 6x. So that's going to give me a new system. 6x minus 8y equals negative 24, minus 6x plus 8y equals 24. Okay? And now I add them. And look what happens. 0 plus 0 equals 0. Okay? These two equations represent the same line. This is a dependent system. And these are, it is a consistent system. It has an infinite number of solutions. Any ordered pair that satisfies either equation will be a solution. Now what if I had added those two and I got 0 equals 8? Then I would know that my system was inconsistent because they would have no intersection. Okay? That's elimination. Now these same techniques work for a system that is not linear. Okay? And that simply means one or both of the equations have a variable that's raised to more than the first power. But we still use the same techniques. Graphing we use to check. It's not usually our first choice, as we've seen before. It's easier to do it algebraically. If I look at this system, now what am I trying to do? I'm trying to get an equation in just one variable. There's a couple of options. One thing that I might think of is substitution. Because look, what if I subtract the second equation from the first? I should eliminate one of my variables. So I'll subtract or add the opposite, but when I do that, I change the sign of each term. Okay? So I'm going to use elimination. I'm going to subtract so that the y's cancel. And again, I get 0 equals x squared minus x, and these two cancel. Okay, and notice that I have a quadratic equation, so I solve it by factoring. And so it looks like x equals 0, or x equals 1. And then I have to find the corresponding y value. I can plug it into either equation, but it's probably easier to plug it into the second one. So if x equals 0, y equals x plus 1, so it's 0 plus 1, so y equals 1. So I have the ordered pair 0, 1. On the other hand, if x equals 1, y equals 1 plus 1, so y equals 2. And I have the ordered pair 1, 2. Now I want to check. Let's check by plugging into the second equation. Okay? If I plug in 0 for y, 1 for y rather, and 0 for x, do I get a true statement? Yep. So it checks in equation 1. Let's try the second ordered pair in, try the ordered pair in the second equation. And let's see, so y is 2. And sure enough, 2 equals 2. So both of those work, so this equation has two solutions, 0, 1 and 1, 2. Okay? Now we can confirm that by graphing. These are two simple equations. The first one is just the parabola y equals x squared plus 1. And we know that that just shifts that parabola up 1 unit. And I'm going to be a little bit precise because remember I'm trying to find the points of intersection. So I get the first equation. The second equation is a straight line, y equals x plus 1. And it has an intercept at 0, 1. And also, let's see, if y is 0, x would have to be negative 1. So it looks like this, and if I draw that line, we find our 2 points of intersection. So this is an easy enough equation that we could have actually done it graphically if we wanted. Okay? All right. Let's take a break here.